Summing up. A. Atomic mass and molecular mass. Measuring the mass of an atom involves comparing its mass with the mass of a chosen reference atom. The relative atomic mass of an element is its mass relative to the mass of an atom of carbon-12. The relative molecular mass is equal to the sum of the atomic masses of the elements that make up the molecule. Both the atomic mass and the molecular mass are expressed with the atomic mass unit, or Dalton, U. U is equal to 1/12 the mass of an atom of carbon-12, that is, 1.611 times 10 to the power of minus 27 kilograms. B. Counting with moles. The mole is the unit of measure for the amount of a substance in the International System of Measurements, SI. A mole is the amount of substance that contains a number of particles, atoms, molecules, or ions equal to the number of atoms in 12 grams of carbon-12. The molar mass m of an element or a molecule is equal to its atomic mass or relative molecular mass expressed in grams over moles. Weighing a mole of a substance on a scale is equivalent to weighing a quantity in grams equal to its molar mass. For example, 1 mole of oxygen weighs 16 grams. 1 mole of any substance always contains a fixed number of particles, atoms, molecules, or ions. This value is Avogadro's number, uppercase N, equal to 6.022 times 10 to the power of 23. The number of moles N contained in a sample is obtained by dividing the mass m of the sample, G, by its molar mass, grams over moles. C. Chemical formulas. Every compound has its characteristic chemical formula in which the symbols indicate the constituent elements and the numerical indices define the combination ratios of the constituent atoms. The combination ratios between atoms enables the combination ratios of the masses of the elements that form the compound to be derived, and thereby to be expressed in the form of percentages of the composition. The percent, or percentage composition of a compound can be used to determine the effective mass of an element contained in a given mass of the compound. By means of quantitative analysis, the percentage masses of various elements are determined experimentally, from which the empirical formula of the compound being analyzed is obtained. This formula describes the minimum combination ratio in which atoms combine to form the molecule. To determine the molecular formula of a compound, it is necessary to measure experimentally its molecular mass. The real molecular mass of a compound may be a multiple of the empirical formula.